All right, welcome back once again to our discussion of different kinds of arguments. Now, what we're doing in this video is moving on to chapter 4 in the Vaughan textbook, where we look specifically at different deductive argumentative patterns. Right? Again, we are trying to familiarize ourselves with various deductive argumentative patterns or the different kinds of forms. And in doing so, we're going to introduce different rules of inference. These are sort of the things that we are able to use, the rules we are able to apply that allows us to make different inferences, derive different statements from previous statements. And this is going to help us determine whether an argument is deductive or inductive. And one of the things that we're going to do right here at the very beginning, and we are going to continue to do in the next couple of weeks, is we're going to start symbolizing our statements. And this is because oftentimes philosophers have thought that it's better to focus on the different form or structure when we remove the content. That way we can see the structure itself and focus on what that structure is rather than being bogged down by the details of what the statements are actually saying. So what we will do then is essentially just use different letters as variables in order to symbolize different statements. So in this case, I'm going to use P, Q, R, and S. So we can take a statement like, if this job is worth doing, then it's worth doing well. And we'll symbolize this as if P, then Q. So we should represent the sentence, quote, the job is worth doing, end quote, as P. And we're going to represent the sentence, quote, it's worth doing well, end quote, as Q. So then we can put the argument into the following form. We can say, if P, then Q. P, therefore Q. Now notice that the first line of this argument that says if P then Q, that particular line, that statement has a very specific name. It's called a conditional statement. And that's because of the logical connective that's being used, right? So here we actually have two different statements that are connected by a logical connective. And that actually makes it a compound statement, right? So we have two sort of atomic statements. The first one that says P and the second one that says Q, and then we connect these together with a logical connective. And in this case, the logical connective is just the conditional, the if and the then. And the two statements that constitute this larger statement, the larger conditional statement, are composed of two different parts, right? One part is called the antecedent, and the other part is called the consequent, right? So the antecedent is going to be the part that says P, right? It's the part that comes after the if and before the then. And the consequent of the conditional statement is called the Q. And that's the part that comes after the then. So when we're talking about logical connectives, we're essentially getting at the logical relationship between different statements, the logical relationship that connects different statements. But we need to be careful here when we're translating conditional statements. There may be situations where the order is not immediately obvious. So take, for instance, the statement, you will do well on the test only if you study. Well, it's not going to be translated, if you do well on the test, then you will study. In that particular case, the only if tells us that the part of the statement that follows it is the antecedent, not the consequent. So really what this statement should be translated as is, if you study, then you will do well on the test. Now, having introduced this logical connective that we're calling conditional, we now have two very important deductive argumentative patterns. The first one is called modus ponens. Modus ponens happens when one is affirming the antecedent, the P part. All arguments that have this form of modus ponens will be valid, right? That is a valid inference. And again, this is just if P, then Q, P, therefore Q. And so we can see that here in this particular example. If Austin is happy, then Barb is happy. Austin is happy, so Barb is happy, right? If P, then Q, P, therefore Q. Another very important deductive argumentative pattern or form is called the modus tollens. And modus tollens occurs when we deny the consequent, right? All arguments that have this particular form are going to be logically valid in the same way that modus ponens was, right? So here we have if P, then Q, not Q, so not P. So again, in the toy example I've got here, it says if P, then Q, not Q, therefore not P. And again, we can see by looking at this toy example I have here, if Austin is happy, then Barb is happy. But Barb is not happy, therefore Austin is not happy. Now, I think that it'll be helpful for you to try to go through different examples and maybe even create your own example of both modus ponens and modus tollens type arguments. These argumentative patterns are very common, and you'll be able to get a sense of how they work if you spend a little bit of time practicing them. There's some practice at the end of the chapter, but I think it's also helpful just to kind of create your own. You can literally use any sort of simple statement, any statement at all, just conjoin them together with this if and then. And again, we can imagine if the premises are true, does the conclusion necessarily follow? And the reason why we know that these are both good rules of inference, the modus tollens as well as modus ponens, is because it turns out that it would be impossible to imagine the conclusion being false if we are assuming, if we're just hypothetically stipulating that the premises are in fact true, even though they may not be true at all. Right. So you can create your own toy example similar to the absurd sort of example that I went through in the last video where, recall I said, if the moon is made out of cheese and the ocean is made out of wine, the moon is made out of cheese, therefore the oceans are made out of wine, right? You can literally come up with any sort of example as long as it follows this form, these different logical forms with regard to modus tollens as well as modus ponens. But let's go ahead and move on to some other examples of very, very common sort of rules of inference that we have. Here we've got a basic kind of syllogism. For our purposes, a syllogism is going to be a deductive argument that is comprised of three statements, and two of them are going to be premises, and one of the statement will be a conclusion. So the toy example I've got here says, all Martians love the movie Mars Attacks. Jones is a Martian, therefore Jones loves the movie Mars Attacks. So again, if the premises are true, then the conclusion follows necessarily, right? It would have to be true also. It would be impossible for this conclusion to be false if it really is the case that all Martians love the movie Mars Attacks and Jones is a Martian. Another common kind of syllogism is what we call hypothetical syllogism. This is a kind of syllogism that uses a very specific conditional statement. Here it says, if the enemy attacks at dawn, then the war will be over. If the war will be over, then the economy will crash. Therefore, if the enemy attacks at dawn, then the economy will crash. So notice that we've got three different conditional statements, right? So there's three different statements here, which makes it a hypothetical syllogism, where the first two statements are premises, the third statement is the conclusion. But now we've got conditionals for each of the different statements, right? If P, then Q, if Q, then R, therefore, if P, then R. So we can imagine this being a point about transitivity, right? Where we are sort of eliminating the Q's and going straight from P to R. Finally, we have another syllogism, which is called disjunctive syllogism. This is a kind of syllogism that uses a very specific sort of disjunctive statement, right? Where disjunctive means or. It's either this or it's that. It can't be both. Right. So the example I've got here says, either Sam will go to McDonald's for dinner or Sam will go to Whataburger for dinner. When I originally wrote this handout, I was teaching at UTSA in San Antonio. And of course, Whataburger is very, very common in Texas. And I was eating quite a bit of Whataburger at the time. And so I think I had Whataburger on the mind. But nonetheless, you get the basic idea, right? Either Sam will go to McDonald's or Sam will go to Whataburger. Sam will not go to McDonald's, therefore Sam will go to Whataburger. Again, we can imagine whether the conclusion is false while the premises are true. And in this case, it would be impossible for the conclusion to be false while we're assuming the premises are true. And so I think it will also be helpful for you to try to create your own examples of these different sorts of syllogism, hypothetical syllogism, disjunctive syllogism, and so on. Going through the examples in the back of the book will help, and trying to create your own examples, I think, is the best way to sort of get a sense of how these different rules of inference work. So I really do think that going through and creating your own examples will be very helpful. In the next video, we're going to look at different formal fallacies that have to do with these different logical forms. So that's what we will do in the next video.